Hey there, thanks for tuning into CMTEQ channel. So, what is PCB etching? Well, PCB etching is the process of removing unwanted copper from your PCB. Yeah, that's basically what PCB etching is, and that is the same process that is applied in industries when they develop printed circuit board. Now, so PCBs, like you see this one here, the real one, the physical one, unlike this virtual one, is usually made of FR4 material, like this one here. That's FR4 material, would be for this PCB. They are metal core and some other type of material as well for radio frequency PCBs. So when these FR4 PCBs are done, they are usually covered with a layer of copper. Well, that copper layer usually have a thickness of couple of micrometers, usually 70 or 35 micrometers. So all you need is basically design your PCB trace, your tracks, and draw it on that copper, and then pass it through the etching process, so you only left with your trace or your tracks. In other words, your wires where your current is going to go through. I'm going to show you what I'm talking about right now. So here is a PCB, okay? So let's go to the 2D version first. So here is a routing. Now, where am I coming from? I'm coming from here, the schematic, okay? So the schematic have been developed. So this is a schematic for the universal motor driver that I made a tutorial months ago. Okay. So now I imported the schematic into the PCB environment, and I've done my draw, my layout, and everything is in place as I want them. So now if I want to develop this PCB, I can generate the Gerbers file, which I talked on that video, and you will upload it to GLC or some other manufacturers to get your PCBs done. Now, what if you want to develop this PCB at home? Well, this is what you need to do. You must generate the artwork, okay? So you need to generate the artwork so that you can transfer that artwork into a PCB copper plate, and then remove the unwanted copper and only be left with what you need. So these are my tracks, right? This one on the blue are my tracks, and they are basically on the bottom layer. Then I've got my components and everything on the designator. So when designing or when etching, we don't need the designators, right? We don't want designator to be etched. They're usually printed on salt screen using different other method. But for your tracks only, your components, you only need the tracks where your current will flow, and obviously the holes to drill for through hole components. So when doing the artwork, you not going to transfer these designators components name into the copper, because it might actually short and create problems. So you only need the copper trace. So by hitting 3 on Altium Designer, we go into a 3D mode. Now we are in 3D mode. Shift S and move to the bottom layer where my components are, my routing is. Then you can see the copper trace where my tracks are. So this is what I need. So you can clearly see where my true hole component will go, and my SMT component will go, and my PCB track. So this is all I want to be left on a copper board or FR4 board. The rest must be removed. So that's the unwanted copper. So what must be left? Only the trace here. So after you done etching, you only going to have something like this, and then you start soldering your components, and you'll have a finished product. Now to do that, you need to follow a certain process. So follow along and you'll see how to create that artwork. So you come to File, Print. It will take some time because it's going to go through all the layers. Then it will pop up. Now you see your PCB is actually missing. So you have to go through the pages to find where your PCB is. There we are. here, we've got designators, we've got the dimensions, we've got all sorts of things, and we don't want these things on our copper, right? We only want the copper trace that I showed you guys earlier. So now, how do you get rid of all these other pages? Well, you have to come to pages, and you can see there is 35 out of 30 pages that are actually selected. So now, you know that your layout or your tracks, as I've shown, they are on the bottom layer. Okay? Now, you don't need all these layers, all these designators and other things that are featuring here. You only need a copper track that's on bottom layer. So now you can start disabling. So now you can come already here, put the top layer off. Okay? Then component layer pairs. You don't need all of these, so you can just turn them all off, right? Then you come here on mechanical layers. Okay, you need PCB outline. All the rest you don't need them, so you can turn all off, and then you turn PCB outline on. Then you come again here on other layers. You don't need all these layers, but you need a multi-layer, which basically is a layer where your drills or the through holes components will be soldered on. So disable all of them and bring the multi-layer back. Now you refresh. Now you can see your PCB is now here at the corner. You can see your PCB is now here at the corner, but now your tracks, they are not black like black ink for laser printer toner. So what you have to do now here is you have to go back to the bottom layer, click on it and select black there. Then you refresh and you can see now your tracks are now black. Now, right now here, you can actually print this already, okay? You can print this already by coming back to the general tab here, okay? So you print on actual size, 100%, okay? Paper size, put it A4, okay? Then, obviously here you can select your printer, and then off you print with a specific paper, and you are good to go, and it will go to the next process, which is development with the UV light and then etching, right? Or you can come here and print to PDF, so which means basically you're going to print it to PDF. So when you select print, you're going to print to PDF. It will basically save it somewhere in your computer. You can just save the PDF and you can be printing it sometime later. That is for printing positive PCB, so that basically if your PCB come with positive photoresist material. So what we just did there, we printed the artwork for positive photoresist, but a lot of PCBs FR4 material, when they come with that copper layer, then they spray them with photoresist material which are often negative, right? Or sometimes positive. So what you have to do now is, if your photoresist material are negative, then you need to invert your artwork. So I'm gonna go back to file and print again. So right now, this here is positive because your UV will not go through the black, okay? It will only go through the white area, and then after exposure that will go through etching process, and all the area where your UV went, they will actually be etched out. You only have your PCB tracks left here with the black area. But now remember, while you are etching at home, you also need to increase your copper here on the holes. Otherwise, when you're going to drill here, you're going to have problem, okay? You're going to have problem because the copper will go away after you pass like a 1mm drill bit. So how do you solve it? You come here, for instance, you can see this is an LED, okay? You can see it is an LED, right? That's the LED. So now, if you don't want to lose the copper, while after drilling here, you must increase the size of that multi-layer area. So you come here, you can see it's 1.6 millimeter. So you have to change this now to at least 2.2 millimeters. That's what I usually put it up. So you come into the settings, then you just hit 2.2. 2.2. Now you can see it's all thick. Right now you will be fine after drilling. You're not going to lose all your copper. If you're not satisfied, you can increase it, okay, everywhere, so long as you're not going to create some shorting, because you need to respect the spacing here. Okay, when that is done, you can review again here, and you can see that you now have a lot of copper here compared to what it was previously. Now, let's go ahead and create a negative printing, okay, for negative photoresist material. So what you do now here is you have to create a layer, okay. Now, I'm going to take mechanical data 1. I'm going to create a layer here that will be called, I will fill it up, and then I'm going to change that layer or that plane into a black color, and then change my tracks from black to white. That will basically mean I just invert the color. So, which means I'm just going to invert what you see here, okay. So I need to invert this, make a negative image of it. So the white area become black, the black area become white. Right. Now to do that, we're going to, first of all, we're going to place that layer. I'm on mechanical data 1. Then I will do a fill. Like that. Then, sometimes you don't want to see all these designators because you don't need them. You only want your copper. So all you can do is to come here and just select bottom. So when you do this, you basically only seeing the copper that you actually need. Then you can disable the bottom overlay because you don't need that as well. Okay, keep out layer, you don't need that as well. So you basically will only be left with what you actually going to be printing. Okay, now you can bring that mechanical data 1 back. There it is. Now you go back to printing once again. Now you're not seeing that layer you just added. Don't worry, you go to pages. Okay, now remember, when you are printing for, if your tracks, they are on bottom layer, you do not need to mirror your image. Okay, that's another option. So if your tracks, your PCB routing is on the bottom layer, you don't have to mirror your layers. But if it's on the top layer, then you have to mirror it. And when you transfer your artwork on the PCB, it's going to be a correct representation. But if you do not mirror it and your PCB is on the top layer, then it's going to be inverted. It will be upside down. But now because my tracks are on the bottom layer, so I don't have to mirror it. I will just leave it like that because it's going either way at the bottom layer where the transfer is going to happen. So I leave that custom like that. So I come back to my layers. Okay, now I need to enable the mechanical data 1. Where is it? Mechanical data 1. It must be somewhere here. Component layer pairs. Mechanical data 1. Okay, it's not here. There is mechanical data 1. So I enable it and I refresh. Now you can see there it is. So what I'm going to do is I'm going to click on it and make it black. Now when I make it black, you'll see my tracks are gone. Okay, my tracks are gone. Now because I want my tracks back, so I have to come back to the bottom layer here. Let's just add this top layer again. Okay, some other layers they are here that we don't need them. Just add them. Just hide them. Then I click on my bottom layer. Then I change it from black to white. Okay, then I refresh. now you can see I've got my tracks, okay? But now I'm missing my multi-layer here where the holes are going to be drilled. It's still in black there. So what I need to do then is to come on multi-layer and also change it to white. There you go. So now the image have been inverted, and you also need to do that on your PCB outline so that it must be properly white, otherwise it's going to fade out when you etch it. So PCB outline and also change that to white. Right, now you can see that your PCB artwork have been properly inverted. But now remember, after you print this out, it goes into the UV development. You will need to drill through here. So these are your guide where you're going to drill with your 1mm bit. So if there is no proper dark spot here, so that basically means this area is not going to be etched. So you won't have a guide where to drill your PCB. So you need to make this area to be properly black as well. Then you can print. You can drill it without causing problem. So now to do that, you need to do another trick here. So now the trick to create your guide spot for your drilling is by placing a pad. So you place the pad into your PCB area, right? Your working environment, which is by default on multi-layer. Then you have to change it. I often choose selective gold bottom. You can choose any layer, but it must not be the same as the mechanical data one, which you have already inverted a field. So you select selective gold bottom. So now you need to enable it because it's just hidden. So show the layer, selective gold bottom. There it is. Double click on it so you can change the size because it's 1.5mm by default, which is too big. You're going to use a 1mm drill bit, so it must be 1mm. Okay, now you can go ahead and start copying here right on the center, and you need to paste it on the center of your true hole component where you're going to be drilling, right there on the center. And this process will take you some time if you've got a lot of true hole component. So you have to be patient and do all of them. Now, if you want to check your progress, you have to go back, File, Print. Okay. Now you need to go to Pages, and you must enable the selective gold bottom. There it is, selective gold. Just enable there and change the color to black as well, because you want it to feature right there on the center where it's gray there. So now you can refresh. Now you can only see the one sitting on the side there, which is this one here. We change it to black here, but you want to see them right on the center of your true hole component here. Okay, so now to solve that problem, you have to come on the layers order here. There is your selective gold bottom, so move it up where you must move it on top of the bottom layer where you're, or on top of the bottom layer and multi-layer. So which must be all the way at the top, like that. Now refresh. Now after refreshing, you can see they are populated. Okay, now you can see your guide is very much visible. Now you will be able to drill after etching because they're going to be because the area in the dark in negative printing will be etched out, and you'll be able to drill it through. Okay, now your PCB is ready for printing it into a tracing dedicated paper with laser printer, and then put it into a universal developer, and then take it through the etching process. So this is how you create PCB artwork, okay, for PCB etching. And make sure when you are printing to print the actual size, okay? Otherwise, if you do not do that, you're going to print oversized and your components are not going to match after the transfer. Now, another thing to note here is if you want to print multiple instances, or you want to multiply these on a single sheet of paper, all you have to do is to basically copy your PCB layout. In doing so, you have to move your mechanical data layer away, copy your PCB like that. Then you have to center where you are copying it from. Then just make sure you move this drill guide away, and you can paste it just close by to the other PCB. You can see the indication there. Then you paste it there. Now you're going to have your PCBs side by side. Then all you have to do now is to bring back the mechanical data one layer. Then you extend it to cover all the PCB. Now you can make multiple copies of this as you want. Then if you go back into your print, you'll be able to see that you've got two PCBs. Now that way, when you're going to etch it on an A4 sheet, or you have a large PCB board as well, you'll be able to get two PCBs at the end of the process. So this is basically how you do it. This is it for this tutorial on how to create a PCB art for PCB etching. Now I can select again my printer, and I'll be ready to print with a laser printer and move into the next process. So if you found this tutorial useful, please give it a thumbs up and subscribe to CMTEQ channel for more tutorial like this. Until next time, cheers.